Welcome everyone to the Geometric View, Season 1, Episode 11. We cover embryonic wave origins, perpetuity, superlooping, helical structuralism, and integrated information systems. All right, wow, we got a lot of people on the call today. Look at this. Okay, we got Richard. Looks like Richard is a guest. Michael McDuffie. Richard Blankenship might be the same person. Kelvin, he's going to be a guest today. I'm just introducing some of the people that I see pulling up. Of course, we got Brighton, we got Brian, Heather. Let me introduce the group here. We got some unavailable calls. Well, welcome to the Geometric View, everyone. Today I'm going to hop right into the episode. So today, the title of our talk is basically waves. We're going to get into waves and wave dynamics. So the title of the piece that I created is Embryonic Wave Origins, Perpetuity, Superlooping, Helical Structuralism, and Integrated Information Systems. Now we're going to go through what all of those things are, and they're all related to waves. And I'm also going to be, as a brief cover of what we're going to be getting into today. I want to first say welcome, and if you're not speaking, please mute the mic. Welcome to the audience. Welcome to everybody here. I'm going to go down a little bit of what we're going to be talking into, and then introduce some of the guest speakers that we have for later in the episode. So we'll go over Cobordisms, homeomorphism, morphologies of waves, wave interference topology, communication, invariant resonant cavities. I just wanted to go down a list of a few things that we're going to be covering to draw the audience in and some of the participants today. And we'll also be getting into Kelvin and Richard's talk about their geometry and how it goes. I believe it will flow seamlessly straight through exactly what we're talking about, because I already looked at some of the pictures and the math is there. So without further ado, we have Kelvin. How you doing, Kelvin? Let me
well. Can you hear me, guys?
Share my screen here. Yep, I can hear you, Richard. Get my screen up. Actually, I think it shows our three faces, and that might be nice for right now during the introduction. So Kelvin, before we get into the waves and stuff, you just want to give us a little brief rundown, some just maybe 2 minutes, 1 minute, 2 minutes about you, and some of the stuff we're going to get into after the episode, and probably during it as well.
Thanks, guys. 2 minutes. Wow. How to condense Tetri-onyx into a quick course.
Oh, no, just yourself. We'll get into your stuff
fine.
Later.
Yeah. My background is I'm an electrical engineer by training with the national telecommunications company, Telstra. I did my initial training with them, electrical engineering, then got into exchange construction, design for the circuitry for the telephony switching. Left that field and joined real estate, then came back into it in the emergency services with the Queensland Fire Service. After a messy marriage breakup, I then sat down one day and discovered what I believe is the basic fundamentals of nature, i.e. Planck's constant, what it looks like from a geometric perspective rather than a mathematical. Of course, if you're using geometry from there, you can extrapolate the mathematics, it all emerges. So spent another 8 years, going on probably about 12 years now, just developing it up, just applying it, seeing where it took me, writing up the results, applying it, And as I developed it, it grew from a nascent thought right through to what we have now. Rich is very familiar with it. Went over, did a conference in Albuquerque, came back, and continued to apply it. What's grown out of a basic thought about squared numbers and closed inductive loops at Planck's constant now encompasses all the fields of science, quantum mechanics, electrodynamics, chemistry, biology, mathematics, cosmology. It's all in there. So Richard can attest to how powerful it is and how intuitive it is. So it absorbs a fair chunk of my life. Even when I'm not working, it's just sitting there bubbling away in my head, and I'm developing new applications, new insights every day.
Okay, that's perfect. That's a wonderful, concise. So where are you located, or where are you stationed out of?
I'm in Brisbane, not so sunny at the moment. It's about 4 a.m. in the morning, so we're waiting for the sun to come up. But
Australia?
Australia, yeah,
okay.
They're down under.
All right, yeah, I can tell by the accent. I just didn't want to be presumptuous. So
No,
Richard, tell us just a couple things about yourself, and then we're going to hop into the episode. Going to go into your guys' stuff briefly afterwards, and then Brighton and I are going to do a separate interview after our talk today with you guys on the Brighton and Buddy show.
All right, guys. You guys can hear me okay?
Nope, you got echo. Someone's got to mute their mic.
Yeah, I'm getting the feedback issue. Everything's double speak. So, anyways, I've just been an advocate.
Oh, yeah, we're not going to be able to deal with me.
No, it was Kelvin. It's fine. Let's try again. Let's try from here.
Okay, well, my entire life I've just been fascinated with science, mathematics, and I've done really well.
Yeah, wait. It's too much.
About 20 years of my life, and then at a certain point in college, I just couldn't.
Hey, Richard.
Some of the concept.
Richard, we gotta stop you, and maybe we can figure this out by the end of the episode. Okay. Because we're gonna get back with you guys, and then I'm gonna just jump right in here. So try to figure that out. We'll do some technical things there, but I'm gonna.
Headphones? Perfect.
Yes, headphones would probably work.
And thank you for joining us. It's such a bright hour of the morning for you guys.
Yes.
That.
Such a wee hour. Oh, you know what? Is my power plugged in? Hang on 1 second, guys.
All right. Sorry about that, guys. Is that any better?
Yeah. That sounds better.
Okay.
Okay, perfect.
Would you like me to continue just for about a couple of minutes?
Yes, please.
Okay, well, I've been kind of sick, so I apologize. When I was in college, I was trying to do some of the things that I saw Kelvin doing. So when I came across his work, it just resonated almost instantly, and I've been hooked. And I'm just kind of here to facilitate the sharing of his information and to introduce kind of the basic concepts before you can kind of take off the runway. I've been endlessly inspired by all of Kelvin's work and his genuine interest in helping humanity. I'm really excited to be here with all of you guys, and been following you for years, and I think it's time that we build a greater community.
Awesome. Sorry, I had to run off. I heard like at the very end of what you said. I had to put my dog in the bathroom. She was definitely whining because my kid just got picked up and went to a friend's house, so my dog was on alert. Sorry, guys. All right. So, okay. You guys can still see my screen, right? You guys seeing my screen? Yep. You should be seeing my screen. Okay. So, So sorry about that, Richard. Had to attend to that. All right, guys, I'm gonna hop right into the episode. And if you guys want to, usually these episodes are like 2 hours or so, but this beginning's usually like an hour. I want to get into your guys' stuff as well, so as not to keep you for 3 hours, because the episodes tend to go at about 3 hours a piece. So I know we're going to be doing an interview later. So, yeah. So that's being said. All right. I shared some images to the group chat. I'm going to pull these up here. I'll start with this one here. Okay. So this is what I meant, or the title of the piece, Embryonic Wave Origins. And I'm just going to leave this piece up here and start. I have a couple, I pretty much listened to different stuff about waves all week, and then incorporated it into what I have already been doing for years with the work that I do. And there's something extremely strange and fascinating that I want to ask you guys what the heck you think it is. Okay, so I shared a video. The video was explaining waves, and it's from the BBC, and I thought it was a really good video. Did anybody get a chance to watch that before this?
On the tornado can?
That's one video. That one's wonderful. What do they call that? The hex. Oh. It's like a vortex. Vortex. I don't know. That one's really cool though. It was more particularly about, here, I'll show you.
They called it the wind hex, buddy.
Yes, wind hex.
Yeah.
Oh man. Okay, since we're talking about wind hex, just for a couple of seconds, we'll put it in the chat. It's not in the chat right now, but there's a video of this design that's just like this. It's a funnel, and you can put anything into it, and it pulverizes anything into a powder. And there's no moving parts. No moving parts. So you could make ormus with this stuff. You know, you could make, which is the mana, monatomic gold. You know, you could put gold in the top and it turn it into a powder and stuff. Put your nutrients in it and have powder. But milk, you know, freaking people were throwing eggs in there to powder eggs. But yeah, it's
Links in the link is in the group chat right now.
Perfect. Thank you, Brighton. Thanks for being right on it there. Oh, looks like he's sending it. Boom. Okay, so we'll pull this up for a second. Just because it brushed my attention this week.
The destructive power of a tornado during a summer storm. Now, Kansas inventor Frank Polifka has harnessed this power in a tornado.
Oh, we did hear.
Wind hex can turn gravel and concrete into dust, pulverize glass and tin cans into powder, even turn chicken feathers into a feather pillow. Raw vegetables like asparagus, broccoli, carrots, peppers, and potatoes can be converted to dry products. Temperatures in the Vortex machine can reach several hundred degrees, so materials are dried almost instantly. Wood shavings are pulverized into fine dust and remanufactured into compressed wood products. Universal Agri-Products is experimenting with different size WinHex machines and a variety of raw materials.
Okay, this one is recycled concrete. And so we're mixing the magic ingredients. We'll just stir that. Let's change the molecular structure of that concrete so it's turned into a very fast-setting cement.
Dehydration experiments have also been done with chicken legs, hearts, gizzards, and yes, even poultry manure.
Also, the corpses of our enemies.
and they're in all.
Nice
It's in all of our
episode.
food. Maybe they put babies in there, and that's why we get so much baby product in our food. Aborted
oil.
fetal stem cells.
How many babies?
I don't know, dude. I'm sorry I went there and said that.
I
It
know,
was
me
because
too.
of it was because of Michael, you instigator.
Listen though,
I'm a
like
bad
the
man.
polarization and the so like this reticular motion, like it's like causing heat when it's ripping these things into
No
pulverized
moving parts.
pieces?
Yeah, it's just basically wind. It's wind probably moving in a hexagonal type of the same pattern that we showed in our show on the episode about lightning. How the hexagon stacking is what builds up the charge and dissipates the charge. So thus, it would be the exact same design in here. It's just layers of hexagons, most likely. So it would be easy to replicate that machine. And buy one and try to find one if you need to powder anything. That's pretty creepy, though. I mean, like, what if that's a new way of cremation? Wouldn't it be a new way of cremation? Like if you want to go there, Michael, you brought it up. You know what I mean?
Say, buddy, could we take another look at your poster that you created for this podcast?
Yes. Boop, boop, boop. So this is the one for this week.
Yeah, it's beautiful work.
Thank you.
I was imagining if this is based on a dodecagon, and if you were to minimize the amount of sides on the polygon by each branch, these bipyramidal or biconal sections would become wider and genuflect at the apice or the knee point, the highest point of the wave, and become wider or thinner by the amount of sides there are on the polygon or branches of waves there are extending outwards.
They flow into each other, yes. If I understand what you're saying, this would be like a Z-pinch. So studying this would be understanding the rheology and rheometry of plasma flows. And when you start stacking waves and waves when you start nesting waves and you get waves within within a wave on a wave waving, as Dan Winter puts it, it's called superlooping. And you get this superlooping right off of the sun. Remember when I was talking about in the earlier episodes how I believed that the beginning of the mind field starts towards the sun and the corona, and how Birkeland currents start there too? I believe that ideas are our ideas for what we are way out here, and we're an extension of them, and we are loops, topological loops of the resonance that comes off of the sun. And this season is really, really informative and exciting because we're going to get into more stuff: the geometry of time, the geometry of death, the geometry of all sorts of weird things in upcoming episodes. Golden scaling. I'm going to introduce golden scaling and how the entire thing is purely gold, like the New Jerusalem talks about the cities being transparent gold. This is down the street of the city. If this were the New Jerusalem, this would be down the street of the city. And this is all based off of sphere stacking. So spherical radiating spheres produce the topological bubbling, if you will, the frothing, which I'm going to get into explaining of the waves. And this is when you get the embryonic waves, the beginning of waves. The beginning of waves is the sixth wave off of the center, and the seventh wave, it's the sixth gate. So it's a process. It is a process that we come off of, and it starts to resonate, and it becomes a chain of resonance that produces the Schumann cavity on the Earth. The Schumann cavity on the Earth is based on all of these waves that are cavitating and commingling, and they are thus what produces through sonic interference and sonotropism and sonobiology the sounds that are recursively vibrating through the Earth, like on the last couple of episodes, creates the plasmoids of the beings and protein synthesis, protein structuring, DNA recursive braiding, and so forth. So the memory is like the ambrosia on the outside, toroid, and the Van Allen belts. And it's also on the inside of the Earth as the mycelial networks and the microvasal networks that are in the Earth. That's without getting into waves. That's just a very brief introduction. And Brighton, I'm going to play some craziness that I don't even know if we can explain. And it involves this. It's the first, if you could go into our chat. I found this earlier this week. It is the first episode that I posted this morning. Not found. Pouring a mirror. Okay, we'll start this at the same time.
What? Okay, here we are. Yeah.
Sorry, guys, for the ad and the space. So I'll talk through the ad and the space, fill it with space. These guys don't like people to use their stuff because we've been banned already once on our other show, but not on this one. So we're going to play it. How about we go right to 440? All right. Click on 440 and I'll pause it.
On there. Go.
Yeah,
All right.
looks like that. They were really accurate with that back in the day. Oh, look at those lens flares rippling off it now. It's very cool. And it's like slowly sort of globbing into the bowl at the bottom there. Yeah.
This is gallium.
It's thinner and thinner as it goes down.
This is gallium.
Like a torrent.
Gallium. Pouring gallium.
Right hand side there, where it's all bouncing up. Maybe we should go in tight on that area and just one more pour, just from like in the bowl. Yeah. Yeah, let's do it.
Here it comes.
Stop.
All right.
Looks like the moon. It does. I don't know. Look at it. Such a weird sight. Oh, whoa. That's weird. They look like diamond. That was a pear. That was like a plumb bob from The Sims. Whoa. That's amazing. Whoa. It looks like something like from Krypton in Man of Steel. Yeah. I'd want to reverse it and see what it looks like. It looks like it's sucking up all the energy. Weird the way it breaks up.
Stop it, please.
Like it.
I didn't want to play too much of their show because these guys are a little persnickety. They don't want their stuff to be out there too long. I don't know what the copyright stuff is on it either.
Yeah. Well, let's just thank them for their work anyway, just in case.
Yeah, and I did call them a little persnickety or whatever. I really appreciate their work, and I watch it all the time, and we almost show it on almost every episode because when you slow things down frame by frame, you really start to see what's happening. Now, what was that, guys? What the heck was that?
Have you guys ever had gallium? Like, have you actually like had a portion of gallium to play with in your hands? Because Lennon asked for it one year for his birthday, so it's kind of non-toxic as long as you don't eat it, and he's smart enough not to do that, so we got it for him. And
No, you can
it is
chew
a
it.
really, yeah. Well, I mean, like, you don't want it.
You
come on.
literally can. You can chew it. You like bubble gum.
No, but you shouldn't.
So
eat
is this
it.
related to? I've never
But
seen
any-
this stuff. Is it related
Don't
to mercury?
swallow it. It's heavy
It's
metal.
pretty messy. It's really
But
messy.
Is it similar
Like,
to
because
mercury?
once
It's like a liquid
fills-
metal.
Yes, but you can
Yes.
touch it. It's safe.
Yes, he was super fascinated with the Terminator and the Terminator 2 and this like morphic metal that would turn into a crazy demon person. So he wanted to play with this metal to see, what it actually felt like. It's very tactile, so he got him some, and it's really cool to play with. It is temperature dependent, how viscous it actually is. But I'll tell you that when it spills, it gets everywhere, and it's very hard to clean up. But it's fun. You can order it on the internet.
So I wanted to talk about why it forms that diamond shape, and why waves form that diamond shape, and why waves are composed of diamonds inside of diamonds. And if you watch Frozen 2, which I'm going to say again and again on every episode, and you're a geometer, it should make you cry. That movie is gorgeous. And it is these diamonds, and Brighton has brought them more to the focus of my attention. I was designing them back in 08 and stuff, and but here it's in these. If you did straight lines instead of curves right here, it'd be the diamond structure. But that's also inherent inside of the waves. So I don't know why heavy metals do that, and why and they say water drops and certain things fall like that. It might just be better for the conservation of energy.
I like the crystalline structure of the metallic liquid.
That too, or the way he poured it. But when you pour water, it tends to do this too. When you pour any water, it will bead like this, or any substance. And the more viscous it gets, I guess the more the wave dynamic would become apparent. Huh? It's kind of weird.
The point at the bottom of the drop looks like it's attracted. There's, you've got the point at the top, which is but a drop is supposed to be droplet-like, round at the bottom.
Right.
Obviously, these are pointed to bottom, so there's an attractive element there. The water is being pulled away from its natural shape. The resistance would create a spherical point at the bottom normally. Like, that's how I see water working, but this has the point. So that's obviously an attractive element there.
Perhaps it's fast speed, because it's a heavier metal. Gravitational pull has a stronger force on it.
And there's a vortex dynamic here with them
that may
connected.
Be. Okay, I could see a vortex happening somehow, maybe.
For sure, there's a vortex dynamic.
There's obviously a pull on the drop.
Well, there's a pull and an attraction, because remember water bridges? And you can create the water bridge.
And it does the same thing. It pulsates just like this.
There is no gravity because it's pulling it horizontally. It isn't pulling it down.
And it's pulling it in tubes within tubes, like we covered.
To say that, let's talk about how an object moves on a wave, that it just moves up and down, right? The object itself moves up and down as the wave passes through it, depending on, you know what I mean? So can we talk about that motion a little bit in relation to the shapes you're showing us?
Absolutely. That brings me to the very top of my talk. Great job. Perfect spot. Good timing. So waves are very much like humans. They're living creatures. They're a process. They have a beginning and they have an end. And by the end of this topic, we will be very familiar with the beginning and the ending of a wave, and the cycles of a human in relation to the cycles of a wave. If you look at this as 20-year spans, 20, 40, 60, 80. There's your 20-year span. There's your lifespan. Here's your whole life. Here's the beginning before you were formed. Here's the end, and you are a wave. So there's void. I believe there's void in void between all experiential moments and void in front of all experiential moments. But experiential moments can dilate from all creatures on all scales, just like these waves dilate within each other. And this would be this braid in here would be the dependence of a dog or dogs on humans, and the human braid is on the outside as the apex predator, and the dog is braided on the inside, dependent on, well, it's not the best example, but there's other things that might be dependent on us. And then the waves cascade and nest inward. And I'll be talking a lot more about that on season 2. But the scientific study of waves began recently in 1942. Which is, I find, kind of hard to believe, because I know there's other studies, scientific studies of waves and optics before that, but we didn't really know surface waves of the ocean and how waves really worked. So scientists found that they could predict accurately the size of the waves on the ocean by measuring the duration of strength. By measuring duration and strength of the wind. So all you have to do is measure the duration of the wind, the strength of the wind, and you can measure the wave caps. Now, what's really interesting is that I think I'm going to cover that in a second. So the transfer waves on the ocean lose very little amount of energy as they start, begin, and go on with their life cycles. They measured all the way from the bottom of Antarctica to the top of Alaska, waves, the same waves. They monitored the very beginning of waves to the very end of waves, and they did this by separate stations monitoring the waves all the way up. And then they built up in Alaska the last station to measure the waves. They built it because they didn't have a station to monitor it, so they had to build an island or something, or build a barge. So what they found is that there's a beginning of waves and an end of waves. Now, the beginning of waves is the surface of waves are always started with wind, and wind on the top of the waves. And the name of these waves are capillary waves. Capillary waves are very light surface tension waves. Capillary waves like this, you might see very, very light, wispy things like this all over a lake. Those are capillary waves. That's how waves start. That's the beginning of waves. Surface waves, surface tension and waves on the ocean or on lakes are like, that's the beginning. So I'm taking that concept and turning our eye to the Doherty network and the Doherty set to show that the same exact concept can happen on an astronomical level and on a subquantum level as a reverse of the Birkeland current and the wave coming in, because all waves have interference and reverse and bounce, and when they do that, they transmit energy. You can't destroy energy, so it transmits into different substrates. So these capillary waves are also referred to as embryonic waves. Embryonic waves. That's umbilical, to say the least, which is what I've been pointing to from the beginning. And I have this umbilical understanding because how many people out there can sense so many different lives, and children that don't know their understand past life cycles and things like that. That's because these past lives are connected. Everything is wrapped up helically. We're bound. We are literally twisted. Everything is super twisted. The ICP might be right with saying everything's so twisted. Wicked clowns. So
Yo. Sorry, every time anybody says ICP, I get like so many songs in my head.
Yeah, we're Detroiters, guys. We're hard Michiganders, and that came out of here. So Fago, what?
What burners? All right, sorry.
Support Detroit, Fago.
Detroit's
River
beautiful,
River
Fago.
Rouge water.
Mm.
So
Hey,
these, yeah.
In the group chat, there's a video on these waves in relation to sound. Yeah, it's just above those. It's at 1:37 p.m. right there.
Brant?
Down one.
Brighton? Oh, right here.
Yeah. And this is a collaboration bringing back Mikey Bergman. It's a collaboration with Mikey Bergman I've had, diagramming what sound waves are. And it relates to Maximilian Falsgraf's work on reflection of bubble fields.
Okay.
But what we see are these sound wave inductions and embedded phi structures that are bipyramidal or biconal, or they propagate such as a nested helical structure would. And the origin, this green truncated octahedron, would be the origin of a sound wave, and then these orange and blue components would be the propagation of that sound wave, and the points where they come in tighter compact between the orange parts or between the blue parts would be where waves have the nesting between their layers, their ringed layers. The expansion that if you have an explosion go off, you'll have multiple layers of
rings.
Sonic booms. Yes. And between those sonic booms is where those nested structures start to come together smaller, because there's less particle density in that area. This is another example of these.
Brighton, you got to give credit to Dan Winter, because that's where Mikey Bergman built those structures out of.
Okay.
Yeah, so just you got to throw that on there, because that's where he got the inspiration from, and it's the exact same thing as what we've been showing. That's right directly inside the structure, and I believe Brighton's right. I don't know if it's a dodecahedron, or truncated dodecahedron, or he's modeled it out that way that it can indeed. Structures can be and indeed be formed like that. And I just love your video and the drowning out of your voice pumping back into and out of the music. It was gorgeous, your presentation just now.
Thank you.
Yeah.
I wanted to bring that in relation to your diagram that you were pulling up.
Oh, yes. It's the exact same thing. You can see that these are basically, when you go inside the Doherty network and the Doherty set, you can see that there's a lot more outer layers of other stuff and nested conics and nested I don't even know the shape of this yet. It's kind of like a crescent. It's a crescent. So, but there's a bunch of different outer layers and inner layers of nested structures that can be formed in so many different ways. That's why we have so many different creatures, because energy can efficiently disperse effectively through these nesting wave cycles in many different ways. If you study different types of hummingbirds, there is only one hummingbird that can eat out of this one flower I didn't write it down, but all I watch is nature shows. And nature teaches us everything we know. And the more you watch it, doesn't even matter what the person's saying in the background, the more you start to understand. I wanted to sort of touch on the base of that is you don't need, for a solid understanding of things, sometimes all you need is observation. You don't need any other sense. So like Love is Watching goes along with the observer of Brighton's work and Brandt and all that going on here. It's really, we're coming closer and closer to identifying the observer and the manifolds that happen sonically out of just observing creates the observer or the observed to act differently. And this happens all the time. This is later in the talk, or maybe it's right now, but there's sentinels in nature. And when a bird such as a crow, a raven, or a blue jay goes into the forest and it calls out, all of a sudden, everything becomes dead silent and everything in the forest knows to shut up. So this is what I'm talking about here. There's resonance that goes on and communication on all scales. And when you're in the forest in hunting season, you know you're in the forest in hunting season because all the animals know too, and you can hear it. There's not one frickin' chirp. You're lucky if you see a bird. Some birds, you know, mostly birds don't care because the small game, a lot of people don't shoot birds. But
they do.
Well,
they
little
do have a
birds,
language.
little baby birds. Sorry.
Well, not just the birds too, though. There was an NPR story about, and you'd have to look it up because I don't have it offhand, but about prairie dogs and the language of prairie dogs, and that this guy was observing them and the chirpings that they were making, and he realized that they were actually speaking to one another. And so, like, this many chirps meant man, this many chirps meant man with dog, this many chirps meant man with gun. And so they were able to yell, "Hey guys, he's got a gun, run!" You know, in their own language, which also, of course, everything else is hearing while they're doing this. So
they're doing like little chirps. These chirps are just one little eyelet, and it's the same thing as a conifer or the cone of a pine cone. It's communication through waves, and communication happens on all scales as a cascade, as a resonance, as this is what I'm proposing, guys. This is towards the end of my talk, or maybe it's right now. This is the time. Hang on one second. Just like we are controlled by the weather, and the weather induces certain behaviors, every sound in nature induces behaviors in an unknown trophic cascade that we have yet to understand, and this opens up a whole new field of science and inquiry in biology, and that's sonobiology. And there's a whole bunch of experiments right off the bat that we can do to test this. And one thing is you can play the sound of a healthy gut. This has already been done, guys. You can play the sound of a healthy coral, just the sound of a healthy coral system to a dying coral system, and it regenerates it. It produces to a thriving a coral ecosystem. This is what I'm saying, guys. This technology, this is real. We can go out in the field right now and go and do this and be scouts of the good news and the good word. We can go out and play the sound of wolves into certain areas and see at certain times. Of course, you can't just play it out like they wouldn't do. You have to sort of know some of the communication. So you'd have to play it at certain times and see how you'd have to document the land probably years ahead of time, or at least have someone already document the land, then start playing certain noises and resonances to certain areas. Okay, here's another idea. A moor. You know what a moor is? A moor is the beginning of a forest. It's very wet. It's always wet, and you can find them here in Michigan.
Don't go into the moors. Sorry, does anybody else just have an American Werewolf in London moment?
The Moors are a type of people too, and Morgan Freeman was a Moor on that one movie with Kevin Costner.
Robin Hood. He was Robin Hood. That was an awesome Robin Hood, by the way.
A really good one. I agree. So more, if you go out, and I'm going to do this, and this has been a long time realization in me, and I'm introducing it through already proven science and trying to validate this model as well at the same time, which I believe is very, very easily done in biology. The more we can validate this model in biology, the more we can start to do other things like test our gut bacteria with certain sounds. It's not hard to test the gut bacteria. You start getting I'm right by U of M, so I'm almost out. I'm in Ann Arbor almost every day, and there's all sorts of different scientists that I just got connected with. One of them is bioinformatics, and I have so many different accesses to labs right now because there's just, honestly, this is a wealth of information for everybody. And not just me, this is the introduction of, I have a place now to introduce my book. So I'm doing my book opening. The name of the book is going to be Sonobiology and how, and we're going to actually open up the Doherty set and the Doherty networks, and I'm going to allow PDFs, AI files, so you can work with it on your own Illustrator or PDF or actual vectorized files, because I want people to start playing with this stuff. And I believe the best way to do that is to just open source it. So I'm going to be opening the can of worms and open sourcing it through a book called the Universe Game, a product, Love is Watching product, and so it's sonobiology. There's a subtitle underneath there, and there's so much information. I could just show pictures, and there's Don Scott's content that he wrote. His review about it. I'm trying to get a review from Rupert Sheldrake. The cascade is happening. Once I get reviews from other people like that, then this content is going to be even more valuable, because this, I believe, is the science of morphic resonance, and we can study morphogenetic fields based off of these filaments. These filaments are actually quaternion symmetry, quaternion filaments of branching, which is how eggs are formed, and how life is actually formed cell by cell using quaternion symmetry. So it's the same symmetry as cell by cell biology. So connecting this with bioinformatics, and Brian Athey is his name, and his son does geometry. He's a geometer. Brighton's actually worked with him, and I'm working with him on a project for Lakes of Fire coming up here with some projective lighting and projectively lighting these figures, these geometric figures, and it's going to be different and interesting, because I've always wanted to get into projective lighting. Sorry, I digress, guys.
That's okay. I was going to say, can we get back to talking about the movement of things on waves too? Because I don't feel like my question was answered.
Yes.
I want to talk about how things move on top of a wave, and are they moved by a wave, or are like in space, horizontally, laterally, or are they only moved up and down? What does the shape of the wave have to do with the object on top of it?
I got just the thing for this.
If I could just say one sentence.
Go ahead. Yeah.
One sentence. Perfect, Brighton. You got a video in the thing in the chat?
I'll show you. Start right now.
Sweet. So waves are not made of water. Just even the water in the waves, the whole ocean, waves are not made of the water. Waves are just as much as my voice is not made of the air. You're hearing my voice by air right now, pressure waves, but that's not my voice. And the voice is not the air, or sorry, that's my voice. My voice is not the air. So you're talking about how waves transmit energy and how they move up and down, like transverse.
Well, not necessarily energy, because when you're talking about the topography of a wave, you're talking about it as if it is like laying on a two-dimensional surface and creating a ripple in that surface, and then you're creating shapes that are three-dimensional waves. So there's at least three vectors happening here, and I want to know how objects that are not part, like you're saying, like the water isn't the wave. So what is happening to the water on the wave?
Let me get back into my head of the conversation here, because I got pulled out for a second, and I will answer these questions one by one. So the beginning of waves, we were talking about capillary waves and how waves have beginnings. Now, what we need to understand is that waves happen on all interference. If there's interference, if there's interface between any substrate, there's waves happening. Everything has waves. Everything is communicating with waves. The sun is wrapped around the earth with all of these waves. So when I say information and energy is being transmitted by waves, that's exactly what's happening on all scales of every single level of wave communication. Now, anybody can try to deny me on that, but that's indeed what's happening. Now you have waves. You have waves on the outside of. Let me get into some pictures here. You have waves on the outside of the Earth that are happening. We covered that in the last episode. These waves are echoic, and they allow us access to the echoic chambers of eternality, which is what we fold out of and how we remember our umbilical silver cord connected to larger elements and larger hierarchical structures, such as religions and things that cascade for eons. Without understanding that knowledge, we just know it. It's part of, Rupert Sheldrake calls it morphic resonance, morphogenetic resonance. So you have these resonances in the mycelial networks, which are in the trees, the microvasal networks that are communicating, telling everything in the forest what's going on, including the amphibians. And these are indicator species. If things are going on that are bad in the environment, you're going to have indicator species that will tell you about it first, because it's water. The water will tell you. Every time it's either the lack of water, or the water source was poisoned, or it was tainted, or the acidity went up. So you got communication on all scales. When you start to think about this stuff, all it is resonance. You got constructive and destructive resonance. Constructive and destructive interference produces harmonies. Inside the Doherty set, this harmonic cascade appears and forms naturally out of compression and rarefaction in the field. The field of what? The field of magnetohydrodynamics, of a continually flowing system, an open, dynamic, living system. Now, this wave interference starts, there's a precursor to it, which is what Russell talked about. Before this braid even starts, there's 6 levels. Like the Buddhists refer to 6 levels of heaven and nirvana, or sex, or other cultures refer to it as a process, a ether. I can't remember what Russell refers to it exactly. There's a name for it. But
could you go back one image?
Yes.
The other way. Yeah. Something about this came up, and I thought, when you have a Vesica Pisces, a perfect Vesica Pisces, where the interference is consecutive occurs where there are square roots between each point.
Yes.
And it's all square root based.
Yes.
You have a perfect Vesica Pisces.
Yep.
I just wanted to point that concept out there, and how it might relate to other projections and other dimensions, such as isometric projection.
Yes, that's a good point. These are all inverse square, inverse cubic, cascading channels. Now, this point to this point to this point, guess what that is? This point to this point to this point.
A phi ratio.
Exactly. 100% exact. I can hold up my golden mean caliper every single time on all channels. This is phase conjugation, which is branched, internested waves of recursions of golden mean scales of waves on all levels, all the way down. That's what creates the and consists the constitution of the ether of Birkeland currents.
I was hoping to answer Heather's question a little bit more in depth. There's a video in the group chat. I hope I'm not cutting you off.
No, that's perfect time.
Yeah, there's a video in the group chat, and it's one with Bill Nye, but the video is very interesting. Yeah, it should be the down at the bottom. It's up 2.
This is you?
Yeah. Here, I'll just post it
it
at the
is.
bottom
No,
again.
I got it.
And if you want to jump in 4 minutes.
Okay.
He has this contraption and he fills it with smoke, and then he hits it and these smoke rings come out. But what gets very interesting is the way that these smoke rings interact with spheres. And it's almost as if these bicones in your chart that you've diagrammed for this podcast.
Excuse me.
that there's a sphere inside each cone. Bicone.
Yes. And that's where the Earth is, in between the bicones.
These toroidal airflow, its toroidal airflow moves around the sphere as a bicone. And this is absolutely incredible. Here he has a flat wall, and you'll see no matter how many times they try to hit this drum and get the wind to blow the candle out, it will not happen because it's flat and it's blocking the airflow. But as soon as he takes 2 sections that they're styrofoam, but it's hemisphere. There's one, and then I'll put another one over, and the wind, when it hits that sphere, it will go around it and blow the candle out as a bicone, as your structure in your chart. Wow. That's what the wind is. But there's a literal torus moving around that bicone. The bicone is the empty space, which a torus moves along, which is really wild. And this actually brings me to another concept. Well, first, that states how wind flow is, let's see, directional. It's perpendicular. There's a perpendicular axis to it, as the torus is based on both perpendicular planes. It's antipose. Yeah, so that's all you need to show that video. But here, I'll pull up another one on the observer. And I'm seeing this not just in waves like smoke rings, but also in planetary and galactic bodies, that there are rotating toroidal observers. Observers, I call it, but it's still a function of rotation. There's another post in the group chat on this toroidal observer.
Okay, so while that's pulling up, I want to state a couple more things about waves. The transfer of energy from one wave, or from one form to another, usually always uses waves. So waves are crucial for the energy state exchanges. Waves are crucial for energy state exchanges or changes. And very little amount of energy is lost when a wave travels across the ocean. This isn't pulling up.
Because I don't think that it's okay. So we were talking about this a little bit, buddy. about the Archimedes screw, right? And
Mhm.
are you guys familiar with a screw pump mechanism? It's like simple machines, right? And there's like a concave spiral that travels around a cylinder, and when something, say like you put a ball in that cylinder or in the concave, as it spins around the cylinder, it moves the ball upward, and eventually will take, like, it will carry the water from a low place to a high place
It's the
via this.
opposite of a gumball machine when a gumball spirals around.
Exactly. So when we think of a wave, we're thinking of it as like an undulation, right? Like the Doppler effect, where it starts on a small space and then it exceeds out along the surface and goes up and down and up and down and up and down, eventually expanding in an area. And when we look at like a ball is set up on top of a wave, if the ball is set on a water wave and the wave goes up and down and up and down and up and down, well, the water might be moving underneath the ball, but the ball itself is staying where it is.
It's
And
static.
so,
That's called a transverse wave.
well, exactly. And that's my point, that
Yeah.
when this energy is moved, whether it be in any type of wave, it's actually a form of Archimedes screw mechanism, where it's a turn process that's carrying the information, it's carrying the energy, it's carrying the load, while turning in this, and the force of the content, whatever the load might be, also adds to the energy. It adds to the circumference. It adds to all of this. So where it's very much like the way when a pebble drops in, the circle starts off small and the waves are closer together in that Doppler form where it moves out. So this is happening in the same mechanism, but in a three-dimensional vortice, right? It's actually pulling the energy up and around itself in an extremely efficient very efficient manner, much like an Archimedes screw, but because it's expanding, because it's creating more space inside. So that's how, like, I feel it, I see it, that's how it seems to work. And any time I apply it, something over it, it seems to work in that way. It comes down to very simple machines, a screw pump and a wedge, and then it applies to everything where information is being transferred in a wave of a vortice or a torrid. It's very strange.
That reminds me of that turbine, that hydro turbine to power cities.
Exactly.
Do you remember the name of? Anybody remember the name of that? It's just a vortex turbine.
Went to a museum for Leonardo da Vinci, and I remember there was this video where they're showing they've created these Archimedean helical pumps at massive scales as an experiment in one dam. I think it was a dam. And it's really wild to see at a macro scale that it also works.
So look at this, guys. If you haven't seen this yet.
Think about a bug's wings, right? Think about that guy who makes wings you can fly on, like beetles' wings, and the principle is the same, except like at a very, very, very small scale multiplied over a surface area.
Nano scale. It's all about nanoscale ridges. And now with 3D printers, we should be able to print with nanoscale ridges and fly. We should be able to make materials that we could flap with our wings, and certain things should be able to pick up our body mass, but the wings would be a little long. So this is what I was talking about.
Fish friendly. That's nice.
Yeah. This is gorgeous, and it's enough to power like a city. It's just one moving part, one turbine right there. And you could dam it up for repair if you have to repair it. More stuff towards the vortexture, which I can't wait to do the geometry of the vortex. That one's going to be fun. So we'll probably cover that later. So transverse waves. Yeah, that is one type of wave, and this is a very efficient type of mechanism, literally a mechanic wave, using a mechanistic way of using a mechanic wave, like a quantum mechanic wave almost. But there is a lot of different types of waves, and those were a couple of them. So what waves really reveal is the hidden. Waves reveal what is normally hidden from view. You can actually see energy in action. That's what's happening. So that's what waves reveal, is what's normally hidden from view. The wind is hidden from view, and then the wind hits the water, and the water starts rippling, and we can see that energy in action. So it's been our observation in nature and biomimicry to create things in nature based off of looking at the wind, seeing energy moving. You have the windmill. You have all of this is just very simple. When you start to get into this type of understanding, all of a sudden the mechanics is very, very simple to understand. You're beyond a mechanical engineer because you can explain it to someone. You can build it yourself. It's simple principles. I mean, not beyond a mechanical engineer. You know what I'm saying, though. You at least get some basic understanding of some of the stuff. So more waves.
You want to see if the other video is set up on the Facebook tab.
I just want to say one more thing about that screw mechanism too, is that when he allows it to go around the sphere, when it goes around the sphere and it's allowed to go around the sphere, it's because it allows for that continuation of motion in the circular form. When it hits that blockade, it's no longer allowed to travel, right? So then it's like diffused, probably radially or however the shape of the wave actually hits. But you know, that's why it breaks off into that illustration that you didn't know what you were going to call the shape of it, that was like a crescent in that way, because as it hits that circular shape, that spherical shape, it allows those rotations to continue in smaller portions.
Well, we can see, yeah, you can totally see that in Russell's work here, that conics, everything is conical. This is one of my favorite here. You can see you can see exactly what's going on. It's a lenticular universe. It's a hollow universe. It is a mind universe. These mind fields are created right around the sun, and then they helically bind and wound into cavities, resonant cavities. I'll show you resonant cavities. Cobordisms, homeomorphisms. Homeomorphisms are basically taking the topology of one shape and turning it into another shape, and it's the same shape. So a coffee mug is a torus. It's the same thing because there's not another hole in it. You don't have to create another hole in it to make it. So homeomorphisms are like that.
Do we have an image of the the Klein mug?
Yeah, there's a whole bunch of different ones. I'm just touching on this briefly because I want to get into the morphology of waves. So just like homeomorphisms exist topologically on substrates, there is also homeomorphisms of waves, and I'm really keen on trying to get an understanding of sympathetic vibratory physics and sympathetic waves and sympathetic resonance, because that's ultimately the howling that I'm talking about, that the wolves are creating the change in the meander of the rivers and the fish and everything, because the fish are going to feel that vibration and move and hide. Everything moves and darts, and they're just mimicking the mirror cascade. That's what waves do. All waves mirror themselves. They cascade, they resonate. When they hit one substance, there's a transfer of energy, and the transfer becomes from one state to another. It becomes hexagonally, the charge from one object. If I were to touch this mug and it sparked me, the charge from it changed the energy state of it and me at the same time. And so there's waves, there's waves on the surface of things, there's waves everywhere. And I could get into the boring part of like the math of it, and frequency is defined by how many waves per second, and frequency and wavelengths are inversely related, and that makes sense. But I don't like to really, I don't want to bore people with math. I want to show them how these helical knots and morphologies and cobordisms are changed from one state to another using sound. You can even see that shapes like this start to form when you resonate anything. What's that fluid? That non-Newtonian fluid. If you get a non-Newtonian fluid and you resonate sound with it, it starts to create bodies like this. And that's what homeomorphism is, and cobordisms. Cobordisms are like the same thing. This is how energy and waves travel through the cylinders and the cylindrical branching of the shapes. So this is the basis of waves, and how waves recur and mirror from the sun, hit the earth, echo in the earth, and start to branch into living systems. That's the morphologies of waves that I'm trying to talk about. I don't even know if there's a proper name for it. Pretty sure it's sympathetic waves, but I'm getting deeper into it, into the science of the sonobiology of it, and basic sonic origins, the sonic electrosonic origins of things, because it's ultimately electric and it's also sonic. So when you get when you mix electro and sonic together, you start to get the waves, the Whistler waves that we were talking about on the last episode. You start to see the cylinders that I'm talking about. You start to see the Doherty set, the stacked cylinders, the what Birkeland currents are composed of, the stacked crystalline lattices of the structure itself. And these Whistler waves eventually become a creature on Earth. They're the sonic resonance of the sun. They're the gut microbiome of the Earth. And they're the resonance that builds the scaffolding for these homeomorphisms and these cobordisms that I'm talking about. So this is the direction. I'm just pointing towards the direction.
So origin of life, almost. I mean, you're talking about
yes,
pretty big
electrosonic origin of electrosonic origin of life and speciation.
So when I listen to you, I'm obviously a huge fan, but
I thought this said Eugene Bagachov. Sorry.
I try to think in terms of how do I communicate the ideas that you're sharing with me to other people who have less understanding of things, and I think it's one of the things I think about in the very simplest terms, and it really resonated with me as you and I began talking about, or in different forums, is the idea of a record player, and the idea of the grooves on the record are waves, and that the needle reads the wave of the record. The record is communicating all the auditory information that you would ever want to hear from CCR or your favorite band. And so really, if you think in terms of a record being a vinyl record being a record of auditory information, that's a really interesting transference in and of itself that we understand and relate to on a day-to-day basis. This transference from physical objects to sound, from electricity to physical, all these things start to make more sense when you apply them back to things that we already get. And I think the universe is obviously recording everything, and there are these resonant frequencies, and these resonant frequencies repeat, and these repetition of these frequencies create life. That makes sense to me in a way that it's a layman, as a regular dude. Yeah. I can grasp what you're saying, and that there's truth in it, because it doesn't end with, oh, and by the way, this is heavy science stuff and you wouldn't understand. I can actually apply the information you're presenting to my actual physical life in things I can see and touch. And that makes all the difference to me.
And that's what I've been instructed to do by all my teachers that said, shut the fuck up. No one wants to hear the science part. But then I realized, and basically the number one question was, why do I need to know? Why should I care, bud? Why do I care? You know, break it down to a 2-year-old, break it down to a kindergartner so I can understand it. Nobody understands you. After being told that for 20 years, I'm ready. The student has become the teacher, so I can mix the dabbling of the two, because I'm an ignorant fool, and I'm also very keen on certain subjects. And I use my ignorance to my advantage because I love to learn, and as we all should. Because when someone says something, you should. That's the definition of humble: being able to listen to someone and change your action or your perception and learn, and not fight it. You know, not be anyway. So
Yeah,
I'm not trying to
absolutely.
say I'm humble, but you got to explain this to the layman's. You got to explain this on all scales to all brain waves.
But we can
Brave.
understand resonance when we relate to each other. When we,
I just
that
said
aha
brave
moment.
wave. I just said brave wave. That was an aha moment. I am going to
Write it
talk
down.
about a brave wave now. We need to talk about courage, and there isn't enough
Brave
people
waves.
talking about courage in culture
waves.
and being brave, having a brave wave. And
we're going to have to do a dictionary just for you. A dictionary of buddy terms absolutely needs to happen.
oh, this episode is actually brought to you by Booski. Booski is the name of the name of the game today, and Booski means having abundant trees or shrubs of or relating to woods. Booski. Bosky. You can also use it as booskier and booskiest. So if your house is the booskiest, then maybe our sounds will work for our sonobiology experiments at your house, so we can impinge your woods with sonic vibrations and try to dismantle the behavior of the creatures.
Well, just to bring it back to wave discussion, I mean, what we're really talking about is periodic motion. Many things in different substances can wave as a result of a different set of circumstances. But I'd like to get Kelvin's idea on how to look at this at the quantum level to show the 360-degree waveform, whether it's just in photons, in frequencies, or whether it is moving particles and what results in those scenarios.
Kelvin, feel free to if you know how to take the screen. I don't know if you know how. You can also tell me. I can surf still and pull up some articles, or you can share them in the chat. So there's 3 different ways to do it. You look like Captain Spock. You're like sitting there like, you're going to take us to the moon. I can't wait. I'm excited to see what.
I believe you're still on mute. You're going to want to hit the unmute button.
Yep, you are on mute. I can see. Kelvin.
There you go.
There you go.
An example of my love-hate relationship with Skype.
Now, there should be 2 pieces of paper on top of each other. A symbol looks like one image stacked on another. That should be screen sharing options. You can click on that, and then it'll say you can share your screen.
There we go.
Yep, and then you can share your whole screen. That's what I normally do, is share whole screen.
I've got 3, so I'll pick for one. Can you see that, guys?
Yep, we're on.
Right. Obviously, Tetri-onyx has a different take on how everyone sees things, and it's going to probably stretch the imagination and bend your mind a little bit, but you'll see connections. I've already seen connections. I'm just jumping to where photons come into discussion in my work once I find them. Here we go. Photons themselves are made up of charged particles, bosons. In Tetri-onyx, the boson is Planck's quanta. It's either a positive or negative charge, and that stems from, if you've played with electromagnets young in your life, where you just put a battery in a coil of wire to make a magnetic field. Over here on the right, you'll see that. If the current flows in one direction in a short-circuited inductor, it'll create a south-north direction as indicated by those arrows. Alternatively, if it fluxes in the other direction, it creates a north-south field. They're both sides of the same coin. If you were to create a short-circuited inductor, put a current through it, it's going to flux one direction because it's DC current on one side of that coin, and when viewed from the other side, it's going to be the opposite direction. It's just a mirror symmetry of the same coin. These coins, or Planck quanta, come together to form photons, because each Planck coin has a charge. So plus and minus come together to form a neutral charge. In the case of a photon, we can detect either the electric or the magnetic fields, but they're starting to already generate those shapes that you've been describing in your presentation slide. You can see the triangular shapes instead of the rounded shapes. It's actually a
Oh, we lost you for a minute. Might have hit a button. Kelvin?
No, I wonder if he's stating that the photons are triangles, tetrahedrons.
Well, remember from our... Go ahead, Kelvin. We can hear you now, I think.
Well, I think Kelvin may have dropped out. Needs to rejoin. It looks like his screen may have froze.
Okay.
But I can kind of lead for just a moment. So what he's saying with the photons is that it's two quanta, and you want to look at them as 2D planar sheets. And so what we're really doing is tiling the plane of energy, and we've got, the connections to...
Why sheets?
Well, that's the difference between just radiant forms of energy and actual topology of material particles.
Okay, I'm going to share my screen and pull this back up until he comes back on. All right.
So what I was hoping that he would pull up there pretty soon, you can see a sine wave. And so the sine wave is a graphical representation of a wave, and he's just showing it in two triangles. He's got the E field component at 90 degrees phase relationships with his magnetic dipoles. And it's just fascinating in its simplicity, and it really does go a long way to unify things like Maxwell and his just electrical ideas. He wanted, looking at Maxwell, from my understanding anyways, he wanted to get a definitive physical model, something that you can conceptualize that isn't just relying on pure mathematics and kind of going into an abstract realm that's not even representation of nature. So obviously what you're pulling up here, I absolutely see the connections with your set, as he was saying, just straight lines versus curves. The curves are just graphic representation.
Yeah. Well, it's a field-aligned current. That's what's going on. That's why we see and we observe some straight lines. But the field-aligned current does have curvature to it, and it does also have all sorts of pixelated geometries, because charge resonates in cavities of geometric forms and formations.
Richard, could we theorize at subatomic scales, would you say that these structures are more Euclidean or hyperbolic?
We would be saying they're the 2D flat Euclidean. at just the quanta of energy. Only
So these are
when
pixelated voxels of information packets.
yeah, I call it trigital instead of digital. 3 unitied.
Love it. Ooh, love it. We might have to have you guys back on for secret hidden episode number number
We'd love
3.
to.
We didn't record an episode number 3 for this show. We purposely left it till the end to record it.
I like it.
As a hidden episode 13 maybe, or 1. I don't know.
Oh, another point I'm seeing right here. We talked about square root forces, and in Kelvin's work, it's just graphically straight up the triangle. And he kind of uses the term scalar in a different way than I think you understand, buddy. Or, you know, I was listening to your episode the other night, and I don't want you guys to be scared of the word scalar.
No, I'm not. Dan Winter is. He hates using the word, or he uses it lightly. You know, but a scalar wave is a longitudinal scale invariant wave.
Yeah, and Kelvin can give you the descriptions on exactly what I'm trying to get at here.
Yeah.
But just if you can conceptualize these triangles or fields of energy that form larger and larger equilateral triangles, it's a scalar area. And we can do the SI units to it. And then you start doing your dimensional analysis with the units. And what Kelvin has built up is a mnemonics that really allows your brain to wrap around the 1D, 2D, and 3D forces. And so a lot of this is just simplified, but obviously it's complex. And as we see these energies manifest across different, what I call substrates, whether we branch from
Is it complexicated?
I always
Shout
like
out
to
to
think
my
of
homegirl.
I always like to think of it as simplex, that just, you know, evolves into complexity. But like I said, Kelvin can probably articulate this point better.
There's some links that he's put in the chat, buddy.
And for everyone on that's gonna view this episode, we're gonna have a nice, solid, in-depth understanding and discussion about this on the Brighton Buddy Show. So you can find that there on YouTube. That's Brighton, as in the town or city or country, whatever. I think there's a few of them. Brighton, Buddy. Go ahead, guys. And yeah, your work. Where can we find the stuff
Kelvin's
that you're working on in
the group chat right now.
Okay. Yeah. Perfect. Shout out to the website. What's the website? Richard?
Well, right now I've got just a Tetri-onyx That's just me taking notes with permission from Kelvin to just post it and kind of propagate it. I've always seen myself as just a facilitator, almost like a kind of journalist following these alternative theories, because I was never convinced that my university education was quite on point. And so it was interesting. After dropping out many times, I ended up discovering that I was in the library all on my own, trying to read these scientific papers and drawing shapes and things. And I just never collapsed on the logical progression that Kelvin did. But when I saw it, it just resonated so immediate. I've been hooked ever since. And I have been seeing tons of synchronicities with your work. Another thing I want to mention about the picture you have right there, the real shiny black line, the thin one, it looks like something Frank Chester mentioned with the Egyptians and the bells, kind of the energy coming off the sun. And so we can relate some of these things to the Chesterhedron, which we'd like to talk about with another guest. But I just see some similarities there in the ancient stuff and all the symbols.
Golden candlesticks. Christian golden
beautiful.
Candlesticks, the golden tubes of oil that lead to the 7 candlesticks. Yeah, dude, it's here. You know, the one who walks amongst the candlesticks. It's all here. And I'm not speaking in code. I'm speaking directly for word for what it says.
Is this an accurate how does your diagram differ from this at subatomic scales? Because there are triangles in this.
That's the thing. See, this wave, this sinusoidal wave here, this nesting wave, that is quaternion symmetry, quaternion braided filament, is only produced by these radiating spheres. And all waves are cube-bound spheres. There's a sphere right here. That's a cube-bound sphere. Walter Russell quote. All waves are cube-bound spheres. In the wave lies the secret of creation. Study the wave and you will understand everything there is to know about the universe. It's all here. And this is all within the Doherty set and the Doherty network. This occurs cascading forever to who knows how big it gets. And every image I'm pulling out here for us to go over and showing everybody real world examples of how these exist in not only nature, energy, future, biology, technology. Every one of these episodes is dedicated to a deeper understanding of what's the word, Heather? Interdisciplinary. It's interdisciplinary in approach towards understanding the oneness of the universe, the universal oneness. I mean, I'd like to think of myself as like an old school type of an old school philosopher where you just look and observe and nature will teach you. A naturalist.
At the bottom of the chat, the group chat, Kelvin's adding some photos. If you want to hit the X there, and scroll down to the bottom.
Ooh, that's
and
more
he's mentioning rhombic or rhombic photons. Reminds me of these bipyramidal or biconal sections. You take them into planes or transversal planes, and you'll have rhombic sections. If you have bipyramids, they're two transversal rhombic planes.
Well, once Kelvin and I combine our our understanding, everybody will understand it a lot easier, because I believe Kelvin's right, and I have a cosmic ray up in the house.
My Skype has been, my computer's shut off. Like my Skype hung up twice, then my computer shut itself off, and then my phone hung up on this call twice so far.
This information.
When the call began and you guys called in, and I'm like, every hour ends in 0 and every day ends in Y. And I'm like, I thought I interrupted something. I'm like, what do I do? Hang up? So I hung up, and about 20 minutes later, I'm like, oh my God, it's Saturday at 1 o'clock. So wow. I'm just back to having time again. So I'll go with the Heather's, what she said about the retrograde. People think, this is why people watch this. One of the very first things told to the Pharaoh when he was allowed to be in charge was, when he left him in the hand of the people, which he wasn't supposed to, Akhenaten actually gave the land away to the people. And that's when they whacked him, and his son Tutankhamun grew up as a boy king, and they raised him up as a tyrant ruler. But really, that's when the Levites, the priesthood took over and infiltrated and started infiltrating the
Levitical priesthood.
Thank you. Because why here Akhenaten was giving away the land, and they saw revenue. That's
where the 12 branches of the New Jerusalem started, the Levitical priesthood.
No, thank you. And I've traced it down, and I'll tell you what, right now, this is where we're at. Now, this is why we talked about the stones and all, you and me, on the very first...
hang on a second, Brian. We're all in, like, some muted place, and I just want to take advantage of it. We might have to hang up the call and I'll recall. But we're going to put this in the episode for sure, because someone's fucking with us.
Well, I'll tell you, on my side, the audio sounds way better than it has.
Really? mind echoing like that too? Because you don't sound bad, buddy. I can hear you completely fine.
Awesome.
Oh, I'm getting this weird slow-mo echo.
Everybody mute your mic and unmute it.
Okay.
Hang on. Everybody hang up. Everybody has to hang up, and then I'll recall, because that's the only way it's gonna happen, guys. Waiting for the rest of you guys to hang up. Thank you kindly. Third time's the charm, Heather says. I believe so. Brenda! Oh, Billy!
Is it?
Not yet. Sometimes I guess the interference happens on a show about waves. When we're talking about sonobiology, I guess it's just the natural.
We're gonna roll with it. Just roll with the waves, guys. Just roll with the waves.
Thanks for rolling with the waves, everyone.
This last week's episode, I listened to it. You know, I didn't even get a chance this week until Friday to listen to that. But no, you know, this stuff here is, and this is why we have such a hard time. You know what I mean? I can't tell you how many phone calls. Once we get to the seriousness of it, you know, everybody's listening anyway, you know, without any kind of conspiracy thoughts on it. You know what I mean? Mm-hmm. Everything's locked into Utah. Let's just go with that. The great cloud in the sky in Utah, the hub of all CIA and everything combined. Facebook, you name it, it's all there. But the idea being that as we keep sharing these truths like this, you know, the resistance is everywhere. You know, the interference is there. But what a great show it was last week. I loved it.
Thank you. I hope this one is even better. I believe that there's so much content that I want to share with everybody and how it relates to the Doherty network that honestly, we're just going to pick it up and know exactly what it means when we hold it in our hands. And then we're going to be able to just intentionally draw on these. Soon we will create the filaments and go into the I3 and actually become part of the neural network of nature, nature's neural network. We will get a bird's eye view of things. But we're not there just yet, or maybe we are, and we just don't know about it. And I'm just intuiting this stuff. Who knows? So there's a lot more to cover on waves. We were in a spot talking about some stuff, but I could take the wheel and drive, because I can take us right back to some more thoughts here. Okay, which I will then. Typically, when a wave reaches the end of its rope, I'm getting a little, because everyone mute their mics, please. Typically, when a wave reaches the end of its rope, so to speak, it is then reflected back. It is a basic tenet of sonobiology and why mimicry could be on all scales, is this reflective nature of reality. So I am still hearing an echo in my voice. That's a little better. Thank you, guys. There is a lot of people on the group in the group today. I really want to say thank you to everybody. We got Sydney twinning on, last name Benjamin. I can't pronounce this. Heo Benjamin. Some other people that I haven't even met yet. So thank you for being here. We'll do introductions at the end of the show. I believe I'm recording, right? Yep, still recording. Okay, so I'm going to go into continuing about waves. Reflection, mimicry, mirror symmetry in the image of. That's why we see Gabriel Kleiman's work here, a cymaticist, a somatic artist, a sculpture artist as well. It works with sound shapes and how they fit together. You have, for every shape, you have counter space, and there's counter shapes around every space, and they nest inside of each other. And the nesting inside of these cobordisms and are basically the sonic bodies of shapes that start happening. I pulled up a video about this non-Newtonian fluid, which is right here. You can see how bodies are created with sound with these non-Newtonian fluids. I can't wait to get into the episode about the geometry of water. The geometry of water is going to be one of my favorite episodes ever. And I'll probably have a couple of guests for sure. Probably Jeremy Pfeiffer, maybe even Edward Grant, or one of the guys that's working on the water project. I'm hoping for Jackson Pollock, or what's his name? Pollock.
Gerald Pollock, but we do that every time, don't we? Especially looking at this, especially watching this thing. Of course, you know.
I need to write his name down again. I mean, I met him. I have a picture with him and like saw his presentation and loved it. But I mean, I can't remember. I already forgot. Gerald Pollock. Gerald. Okay. It's just not that common of a name. It's cool. It's cool. It's cool. We like your name, bro. More slow motion guys.
It'd be wonderful to have Hiro Emoto, I believe his name is, which is Dr. Emoto's son.
Yes, I'm friends with him and I communicate with him. We could probably get him on that episode for the water. But guys, this show's only going to get bigger, bigger, better, and better. I mean, the guests that I've already pulled for the Electric View I could only dream of. The first guest we ever had on any podcast that I've done was Don Scott. So it's like, he's the Don of electrical engineering as far as I'm concerned, and understanding what Birkeland currents are. So you can see these shapes and these that Gabriel Kleiman is creating are similar. So waves are a form of transport of energy. That's what waves are, according to Dr. Richard Porter. Dr. Richard Porter says this, and that's in the BBC documentary. Waves contain energy or power and information. All waves contain information. If everything's broken down to information in bioinformatics or in many different schools of thought, there's black hole physics where things are breaking down into information on the holographic and cosmological levels. So that could be thought of in that manner. Waves are the medium of the information and the information exchange. So it's not always quantum. There's heat waves. There's on every scale. But when you get to smaller scales, sure, you could call them quantum waves if you want. There's packets of energy. I don't have a problem with using some terms of quantum in my verbiage or my lexicon, because I understand a lot of what quantum is, even though they try to present it as you'll never understand it. No, there's quite a few principles that you can understand to get a basic understanding of what they're trying to get at. And you could call it the Planck level, the quantum level, but these types of shapes occur and are recurrent. And that's what I'm saying here is the waves are the medium of the ether, and the waves contain the energy, the power, and information. I couldn't stand Count Chocula. This is how they made us hate counting in school or in Sesame Street.
I know. I was like counting. I love it.
1, 2, we're gonna come after you and kill you and take your baby. 3,
So you're hiding with Oscar the
Grouch. And then I get my depression from Oscar the Grouch. Thanks.
Yeah, we're just in there eating cookies.
Unsolved mysteries. There's a killer and he's next door to you in your house, in your community.
He looks just like your friends.
Help us find the killer in your basement. Call this number.
Get back to waves.
Get back to waves.
Sometime we'll have to do a video on homomorphology in relation to torus and Klein bottles, because there's some really, really wild stuff there and topological laws that involve certain symmetries and how certain mappings only relate to either a torus or Klein bottle, and that sums it all up. Or how if you split a Klein bottle in half, you unzip it, it forms into two Mobius strips.
I seen you post
stuff.
Yeah, I seen you post something about that earlier this week. That was sweet. And thank you for saying sometime we have to do an episode on that, because there's a lot of content for this episode. And as you see, I've already categorically went through and stripped them down to episode by episode. So sometimes things can get distracting, and there's a lot of content. So sticking on the content here, I can't wait to get into this conversation. Hopefully it happens tonight. And we can get into deeper elements of this structure, because it matches right when the conversation bleeped out, I was just about to say I was on the floor doing this geometry and with the Aurora star. The Aurora star is how I received this, and I can show you how on every single level the information from the whole Doherty set is inherent on every single line inside the structure here that Kelvin is showing. Because Kelvin, I broke it. I broke it down into this equilateral harmonization inside of a sphere as well. So once you see how I did it, and I see how you guys are doing it, then our forces are going to be unstoppable. Literally, I can feel it. I can see it. I don't know if Kelvin's back on.
He is, yeah. Kelvin, has any of this been inspired from feeling the field, or a psychedelic or meditative exploration and experience of being in this field? Have you, or there's this term I've created, it's geosynthesis, and it means the experience of morphing as the field. Have you ever been in relation to, as one with the field? Your mic is on.
Oh, so you can't hear me?
Yeah, yeah.
Oh, that's cool. We got a flaky internet here. It's in the process of being fixed. It's the problems of moving into a new house. As I just commented there, all of Tetri-onyx came from a blinding insight in a moment of sheer boredom. I was sitting there and had nothing to do, and started playing around with shapes. And being an electrical engineer, to cut a long story short, I realized that an equilateral triangle can contain a magnetic dipole and an electric field of equal strengths. And from my electrical training, suddenly things started to emerge. The second insight was that equilateral triangles can stack up into a squared field, as it's known in mathematics. And that field, if measured transversely, is the squared numbers are a sum of odd numbers, which again is not what we're taught. I'm just putting in some slides there. And then you can measure that exact same field from top to bottom instead of left to right. Instead of a squared sum of odd numbers, you get even numbers making up that same field, as it's color-coded there, which equates to acceleration, increase, decrease, Newtonian physics, things like that.
When you say field, are you saying that this field morphs, or that it's stagnant? Are you saying that it's pixelated, or that it's curved?
So all the way.
If you think of the Planck quantum itself, the very building block as a short-circuited quantum inductor, the best description I would give you so far as 2D would be to say that it's the soap bubble film that you would form in a triangle. If you made that triangle, dipped it in the soap, pulled it out, you'd have a soap bubble. One side is the mirror image of the other as you look through it. But in the case of energy at the quantum scale, there's actually an electric and a magnetic field that you can model electrically just as a short-circuited inductor with a DC current flowing in it. And those triangles then interact via the electric and the magnetic charges in that shape, that 2D shape, to form sheets, larger sheets, photons, then EM waves made up of photons, self-similar, on every scale. And where you form 4 equilateral triangles together to form a tetrahedra, you have what I term the quantum of matter. It's a 3D closed topology. It's a tetrahedra that excludes the energies or the mass energies of empty space around it, which is just radiated starlight, excludes it from a volume, and that creates an inward pressure, what we term gravity. So 2D are mass energies, whereas 3D are distinct particles in Tetri-onyx.
Have you thought of
slide where that might help?
Have you thought of the larger organic types of fields that are like the magnetosphere and things like that in relation to these triangles? I had an image that I showed here earlier of the sun on the left-hand side, and then the because I believe that if we combine our understandings, and I'll show you later on in the episode tonight, because I'll build another map in between the episodes, because I'm that dude that does, and I already have the map already built, but I can put it together to explain it better. But it shows controlled cavitation using these equilateral triangles and morphologies of the equilateral triangles, how to move through a wall like you're showing here, and like a point source going through a wall and coming back and return recursive cascade. Like light is sticky, it wraps around walls, it's static, and so yes, I'm really looking forward to combining the Aurora Star with your work, because when the episode was about to explode, like I just said, sorry, when the episode just went off, and I was stating that when my daughter was born, I was on the floor sketching these huge maps, and I saw this. So I seen the hierarchical structure that creates this this nested labyrinth of equilateral triangles. So that happened in October of 2007. I'm curious about your events and the dates.
Very similar. Mine was around about the same.
Wow.
2006, 2007.
Wow.
And then I started writing it all up and got the basic germ of the idea of what I've now evolved into about 2,500 pages, as Richard will attest, about 2008. And then spent another 6 years writing it all up, refining it, drawing it, and then put it out to the world in 2012.
Awesome. That's when I started, I think I started disseminating a little bit of my content in 2012 as well, because, hey, it's the end of the world. Might as well put it out there. The government sure loved all of our content.
This kind of tiling, Heather just mentioned that it's argyle, which is a Scottish type of tiling with rhombic planes or equilateral triangles or triangles.
Kelvin, I'm sorry, guys. I have to say this. I'm having an extreme affinity for you right now. By the time of this matching the timeline here, and both of us releasing it in 12, I've had waves. I've gone through 4 series of transitions of this type of geometry. And as you can see, I have many different descriptive maps that are showing the subscalar, the larger scalar, and the hierarchical structure that can house these. And And it's just like it's so interesting because I've been writing to you. I've been writing to everyone else who's been growing and this has been happening and I haven't met them yet, you know? So that's really cool. I know that there's a collective of us out there and people could call us indigo children or whatever you want to call it, but it's hard to find other people like that, the kindred.
Yeah, for sure. I mean, like the thing, as Richard will attest, the thing about Tetri-onyx is once you wrap your head around what you can do with an equilateral triangle and how it matches up in the mathematics that we're playing with emerges, you can quickly use it as a powerful visual and physical tool to model everything from the quantum scale right up to the cosmological. And you can stop a lot of dead ends that you go down mathematically. You can, if you can, as Maxwell Clerk once said and was a big proponent of, if it's mathematically correct, you must be able to physically model it with a physical model. And that's where he was at with his own unified theory. He was trying to build a physical model and he couldn't quite get there as he died, which was a shame. But what we've done now is taken his mathematics and continued to expand upon it. And we've gone to a few dead ends.
Maxwell was a big proponent of the vortex theory, but he had to depart from the vortex theory in order to correctly describe thermodynamics using waves and not a physical substrate. But I think what we're doing right now is combining it correctly, how it should be, using real life dynamical systems on all scales so that there's no confusion on where the scale starts, ends, or continues.
You end up with a very clear model and a very clear path from the quantum up to the cosmological scales using this. And the beauty of it is that anyone can do it. Anyone that picks up a triangle can follow what I've done here and start slotting, coming up with the same answers, coming up with the same understanding and refining what they've been taught along the way. I'm like, obviously I had to relearn a lot that I'd learned. My own understanding of electrodynamics, being an electrical engineer, completely changed.
Are there Pascal functions with these kinds of stackings? Are there Pascal functions in the electric fields? I found this article, and it's a recent article, 2020, and they've said that they found Pascal conductance series in atomic channels. I'll share the article in the group chat for anyone looking for it, but it's very interesting to see that they've actually found a practical application where this has been seen visually, the numbers boil down to show the triangulation. And a question for you: have you experimented with the other two types of uniform tilings in the second dimension, square tiling and hexagonal tiling? What are your discoveries on that? Are these triangles able to morph into squares and hexagons and other forms, but stay at their center?
Obviously, my focus was on equilaterals, but then again, hexagonals are just 6 equilaterals formed, and you do see that where I tile it, equilaterals out into just saying radiant energy in empty space to form the fabric of space-time, if you like. I don't like that term, but you do that, you get hexagonal patterns popping out of it, and you get rhombic or diamond patterns popping out of that. And then, but the big thing I stress in my work is that even those squares can be thought of as a slightly morphed or skewed diamond. The thing that came out immediately was, as I put in those previous slides, that so far as tiling equilaterals, you form squared numbers. So the thing that stuck in my mind from day one, once I started doing this, was that the squared numbers that you find in the mathematics of physics actually relate to equilateral tiling of mass, energy, or Planck quanta within EM fields. You can measure them either as individual Planck quanta, h nu, or you could measure them as a frequency like Einstein did as hf. And don't mix the two together, because one's referring to bosons, equilateral triangles. HF refers to dual sets of bosons or photons in the same scale of waves. So you can look at the tiling of equilateral triangles in a larger EM field, and you can measure it side to side in a transverse fashion, Planck quanta, and get one number. And then you measure them longitudinally from top to bottom in line with the linear momentum or the forces that it can create, and you get a number that's exactly half, because a plus and a minus create one cycle of frequency of diamond. Two equilaterals create a diamond. So a lot of terminology has to be corrected, but I didn't play with squares themselves.
Did you hang on one second, Brighton? Did you, Kelvin? Did you happen to catch our episode on the geometry of lightning?
No. Sorry.
Oh my gosh! Please watch our episode on the geometry of lightning, because it matches your model spot on, and that's how charge distributes its energy. So one way anyway.
Well, you look at the purple on that slide that you're hovering over now, that's your square root per se, linear momentum, expanding in both directions from that central point, or the Z pinch if you like, or the block wall. It expands out in both directions because it's light, but that linear momentum is akin to your lightning strike. If it was a big discharge of energy, i.e. photons concentrated in an area, you'd have the lightning strike traveling down that purple channel, and then side to side of it, you've got different frequencies. There's an earlier slide where I've got let there be light, and that's a more accurate representation than that one of how how different wavelengths of light overlap each other to create white light. You'll have the red larger wavelengths exactly the same per second as the more intense ultraviolet purple light, but they're all layered, superpositioned on each other. Within that, there's in 2D layers. Within that lightning strike, and you get light, or within sunlight, and you get light. All the diffraction prisms are doing is separating that out, because of the different propagation velocities of light in a medium.
So do you believe light is I don't want to ask you all these questions, so many different questions, but do you think light is moving? Because we're doing an interview tonight, but so you think light is a perturbation? Do you think light itself moves, or it's just a perturbation?
Light itself moves. I'll try and find that there's two distinct forms of light, which is one of those slides I sent. Again, I tend to jump from one to the other as I answer the questions, and I feed the information as fast as I can.
Right.
If the you'll see it like a crosshair one, probably further along to your right.
Oh.
There's one.
Is this light that's moving through the field? Quick question: is it moving fluidly through the field, or is it pixelated, turning on and off like it would in Conway's Game of Life?
It's slicing, and 2 slides back from this one will reinforce that. I mean, like, everyone in the mathematical world sees sinusoidal waves as being generated by a unit circle rotating about that, pi radians, etc. An equilateral triangle can also be termed pi radians. So if you measure a photon, which is what's drawn there on the right, and just run a ruler along that from right to left, you'll see that as you go through, you start at the positive electric field at its minimum, grow to a maximal width, back down to a minimum in the center, and then grows negative. So you get a full sine wave of electric fields, and 90 degrees behind that, you get exactly the same thing with a magnetic field, waxing and waning. And of course, the green line at the bottom would be another photon behind it. But what it's getting at is what's perceived as a unit circle rotation of a sphere or something like that, or photons as particles, isn't right. They're actually planar sheets of equilateral EM energy, short-circuited quantum inductors, or in the case of a photon, 2 inductors forming a transform.
I don't mean to interrupt you.
You're right.
Redshift, redshift, blue shift. So what this is saying is basically like that it's just a different angle that we're seeing the light, so it's refracting it back in a different color, maybe not necessarily like the speed of the light, or it could be angular. Let's just leave it at that. Let's just leave that.
Yeah, you could say that, or you could just say that it's because energy propagates outwards and the triangles get larger over time. That would be red shifting. It's the stretching of light, as some tend to describe it. And then again, moving through the electromagnetic field of a star, that light, that equilateral rhombic geometry, is diffracted by the electromagnetic plasma around the sun. It's not a gravitational bending, because once you define mass energy as being planar 2D mass energy, not 3D matter, you realize it's not gravity acting on the photons, it's the changing energy density, i.e. the plasma of the star, that's bending the light. It's the same changing electromagnetic field of the Earth that changes the radio signals coming from GPS satellites down to the Earth. It's not a gravitational effect. It mimics it, but it's not. So there's a lot of things, as Richard will attest. Once you start down this rabbit hole and start following the theory from its start, you end up with a lot of changes in how you understand the mechanics of nature. But at the end of it, you end up with a very simple model that everyone can follow, and everyone can make physical models of not only mass energy, but matter. There's slides on the YouTube channel where Diego at MIT has done up a 3D CAD illustration in Fusion, where we start with the triangle and we go right through to DNA. So we've done all the models. I've done brand new periodic table. Chemistry was my least favorite subject, but it became my biggest book. And it all stems from what you can do with an equilateral triangle with a positive charge on one side, negative on the other. You get your photons, you get your bosons, you get your quarks, you get leptons, baryons, all the elements, and then they will form the chemical building blocks of life right through to DNA. And then you can go on to planets and stars and explain their processes, as you see in one of the other slides down there with the sun. But it all starts from one point. So it's a model that builds up a lot of understanding of how nature works, rather than trying to interpolate it from a top-down view.
Right. I believe I have a hyperbolic understanding of what you have what you have a Euclidean understanding of. Because our models are they can be superimposed. I can put that's what I'm looking forward to tonight, to show you that when you put that structure in here, it builds a star with spherical harmonic resonance. And when you put a circle around it, it becomes a hyperdimensional tetryon that you're talking about. And we'll get into that on the episode. So you're going to have to watch our other show, the Bright and Buddy show, for the audience out there.
Can I ask another? Can I just say another? The reason that I put in those the things about what I put in Fion's window, 3 different versions of it from the OM alphabet, and then I also put in some rock carvings, the curbstones from the Boyne River Valley in Ireland, and the idea is that, see, there's the square root right there, is very, very similar to what it's almost. I mean, you could layer your work on top of Kelvin, your work on top of these images, and have them be applicable to it, which is awesome, because this is an ancient understanding, and I believe that these are diagrams. This is information. This is like a how to understand atmospheric energy and how to refract it and diffract it back into white light usable energy sources and things of that nature. And so what you're illustrating is I just want to show you this, because I don't know if you're aware of this or audience is aware of this, and how this can possibly correlate to what we as humans may have already known. And the chevron images, those diamond shapes are used often in the ancient megalithic art. If you don't mind clicking on one of those stones, not this one, maybe this one, and then there's some at the end that I put that I already have like the drawing over the top of them. See, there's the chevron shapes, there's the chevron shapes, and there you go, that's a good one. I think that they're like diagrams, you know what I'm saying? Like we would draw a motor diagram and just use symbols, and that if we're just like looking at them wrong because we assume that they didn't understand this, and what you're breaking down is an understanding of this, and your diagrams look so much like this. I was like, oh my god, we have to investigate this much further. Look at that one, and that's amazing how similar these things are. And there's like a boundary layer. I did a whole, but I'm not going to get into my crazy work here on this right now, but I would like to discuss this further. And I think that you are really onto something.
Heather, if you're available tonight, you can come on the episode.
What time are you guys doing that?
What time is it, Brighton? I think 5.
Okay, maybe I could do that. I have to drop Lennon off at my brother's. We'll see. Maybe. Thank you. I would love to talk to you guys. Let me just make sure that that's what I can do.
Okay.
But this is really, really important because the 369, right? The 369 and everything is based in the 369, and the solidity of the triangle and trines are very, very important in many terms. So that could go on and on and on. Pyramidal, the trine in astrology, just our ability compositionally and like Renaissance work. I mean, the triangle just pushes throughout, and a lot of it has to do with this. And I think also that this curvature of the line, the allowance of the flow because of the angle at which it hits, is extremely important too. And because of the solidity and just structure of that shape of that equilateral triangle, it allows for a lot of things. So I would really, really like to talk to you deeper about this in relation to that.
I'm sure we'll both get something out of it. Every discussion with Tetri-onyx and its application and how you can tie it in with other work always leads to great insights and more information for both.
Awesome. Yeah, definitely. That's why we're here. That's why we share, right? So we can learn. So it's beautiful work. Oh my God. I was like, because I've looked at your work before, but not while it's being narrated, and this is so much.
Yeah, it's a lot easier to hear it when someone's right out of the horse's mouth, you know.
Yes, definitely.
For sure. It lets me jump from topic to topic and provide the slides that are more impact, as opposed to trying to wade through the 2,000 odd pages and another 1,000 illustrations.
Oh my gosh, this is gorgeous. I couldn't tell what was going on there at first, but there's 4 drops and the sun's coming through them.
Yeah, isn't that Brant Hinderman's photo? That's beautiful. It's just 4 drops on a ceiling. Clay Taylor has some work on light fields and what exactly how the phi ratio is embedded in that little light that's coming off the water droplet there.
So I think it's really cool right now because everybody collectively is coming together and describing models that work and seem to nest or seem to work together. There's for so long of a time been disruptions in the scientific community with novel ideas that are crazy, and the quantum physicists have said the crazier the idea, the more likely it is to stick. And they've come from this way out proportionalized, bamboozled type of embezzlement idea that the crazier the idea, the more likely it'll sell, you know. Which it's more like the more intuitive and the more it makes sense, the more it's right. It's not the model that you know, I like surprises, and the more you surprise me and it matches my model, the more it validates the model, the more the anomalies seem to fit what we're working with. seems to like us like a glove, then it seems like it's better. It just makes sense. It validates yourself and the model that you're working with. Oh, sorry. I heard that in my headphones. I don't know if you guys heard it. All right. So yeah, that was a good brief description and rundown of and correlations to what I was talking about with the electromagnetohydrodynamo, because it is a dynamo, and that's the process. The process of it is the dynamo, and it's dynamic. It's moving. So I have a couple of notes here. I can hop into waves a little bit, and then we can move towards a close. Typically, it lasts till about 4 o'clock. There's some more notes that I have here, and I want to get back into some super looping. So this is just a note I have. Surface waves take 3D energy and transmits it into energy. It transmits its energy into surface waves. So I kind of stumbled on that. Surface waves take 3D energy and transmits its energy into surface waves. They focus the energy. And I talk about surface waves a lot because I understand surface waves on some really crazy level, like the surface waves of Birkeland currents and why Birkeland currents pair off into plasmas, bilayers, dual layers, double layer fixtures, and why there's space in between. That's the kind of understanding that I have of surface waves, not like well, I also know that structured water, the only thing that changes in structured water when you change it from water to structured water using different systems is the surface tension is what changes, nothing else. So the water tightens up. So that leads me to believe that so surface waves occupy a tremendous amount of energy, and it's is structured water focused energy? Is it focusing the water and the waves within it? That just, it gets me thrilled with the idea of us waking up to our motor of the sun every morning, the polarizer, as we get into the positive ions of the day being released. And, I'm always talking about the structured water in our body and how all living creatures have it. And I think that's part of what allows us to communicate through the morphogenetic fields. I think, and have proposed in previous episodes, that the Akasha is geometric. It has a geometric entrance to it. It is literally hexagonal, and it's the model of the ether that Maxwell proposed, the hexagonal model of the ether that Maxwell proposed, which also seems to fit your model here too perfectly, Kelvin.
It's just slightly different geometry, and you can see that the fluxes, as I keep saying, of the energy within the 2D equilateral scalar wave gives the same results, but you don't need the hexagon with like a ball bearing in between it to explain electric and magnetic. They're inherent in a energy flowing in an inductor.
So you're saying that literally there's nothing three-dimensional coming from the sun. It's all two-dimensional.
Two-dimensional, just planar sheets of
just sheets of two-dimensional electromagnetic.
It does
planar sheets. Sure. Okay, and the particles are planar sheets. Planar sheets.
The particle knows the 3D shape. Example of hydrogen, you got the proton and the electron.
That's together. 3D.
Yep, that's 3D.
Okay. It all starts from 2D. It all starts
embedded in the field. They're just like the boat and the 2D sheets of energy are your waves. So you put the boat in the wave, depending on its charge, it's accelerated or one way or the other in that field.
Why do you believe? Why do you believe?
Yeah.
Why do you believe it's 2D? Why can't it be 3D?
Because once you create a 3D topology, you're excluding external mass energies and you're creating gravity. And you don't
you could have it. You could have it in solenoidal figurations of your types of geometries and create like a crystalline labyrinth or a crystalline type of structure stacking. And that makes more sense to me, pairing your idea with the idea of what Birkeland currents are. And I want to actually let me pull up a video because this is going to vibe with you, I think, because it is planar sheets inside the Birkeland current. I don't know why it was designed like that, but it is. Let me see. I'll pull it up. A buddy of ours designed it. Don Scott Argos Vu. I took this video, and the first time Don Scott sat down with a software engineer who designed a Birkeland current, and I happened to be there, so I videotaped the moment because I knew that it was historical. But this is, there's Don Scott, there's David Johnson of Argos Vu, working with Terrence Howard now. I introduced him to Terrence and they got a crew kicking. They vibed out well, so Chris is working with them, and Fractal Woman was working with them as well. Fractal Lady. So where was it inside this where the sheets were? There were sheets. Was it another video? There were sheets and a water bridge. It was like a cosmic water bridge. Oh, I guess this one doesn't have the actual sheets in it. I took 2 videos. But yeah, if you could combine, because I mean, it makes sense. It makes sense. I'm trying to wrap my head around the 2-dimensional, because I have found processes inside of the structure that I work with where there is an actual dynamic process for the breakdown of 3-dimensional matter into 2-dimensional matter, and it goes through a process, and the process does involve one of these actually. So I mean, this is why I'm so keen into trying to understand more and more about this model. So I just keep interfacing with it so well. So I got some more notes here. Waves are happening continuously. We can't stop them. What do we think we are? Superman? What, did you think you were God? You can't stop your thoughts from happening. These are so humbling, these sentences and these sentiments to people who think that they're God. I mean, yeah, you're maybe a co-creator, a cobordism with homeomorphism with God, but you know, ultimately it's an ego thing when you hear people start boasting like that, and I'll yell at anybody for it. And I think that there's clearly higher dimensional things going on that we don't know about. And waves are happening in your brain. We can't stop them from happening. Maybe we like with the Wim Hof method. And if you're a Buddhist monk or something, there might be certain states that we can get into, but we still can't stop the waves from happening because we're not God, and we can't stop other people's waves from happening.
Lateralis by Tool. Their song, and it's all based on the phi ratio, but it's it's like a Romanesco in its own.
Yep, it blossoms.
Yeah, and he is saying that he wishes to, let's see,
I know the pieces fit. Sorry.
That's not the right buddy. That's a totally
wrong
different song.
song.
The body from the mind. And he wants to become one with this spiral, with this cosmological body, as if all spirals are God, and all spirals are, are the electrical conduction that passes through our myelin sheaths and our neurons. All of this, we are spirals.
Yeah. We're helical. Brighton and I did a show on helical, but we didn't release it yet. We have to find it in the cloud or do it again.
Yeah.
So, but yeah. I mean, we are able to tap into the source anytime we want, and anything can get us there, Alice. Yes, we are in Wonderland still, and we've never left the red shoes. We are literally through the looking glass, and it's time to go home. We are in heaven, and we need to remember this. Heaven is a place of mind. It's a state of being. It's a thing that's eternal. And if you have an eternal, if you start thinking on geological timescales, then you start thinking of eons and epochs, and you start thinking about cosmological timescales, and you start wrapping your minds around these larger concepts, then you can start, or your higher selves can start orchestrating your lower selves to understand this shit while you dream at night. Sorry. Okay. So when waves transmit energy and information, waves are typically transient.
Don't miss a moment. Live TV from.
Sorry.
Walter Munk did the math on World War II, and he was the one how we actually started to invade the beaches, storm the beaches of Normandy. We couldn't get in there because we couldn't prognosticate the waves. So thanks to Walter Munk here, he did the math for it, and we figured out that the duration and strength of the wind, by measuring that, you can find out the waves. So they did just that, and the waves all the way from the Antarctic all the way up to Alaska didn't lose hardly any energy. And that's pretty interesting. But by the time they got to the shoreline, they were barely lapping up. So the energy contained in a wave is remarkably persistent. It took 7,000 miles and 2 weeks to measure this in 1942 when they did that. So we're not just metaphorically like a wave. In some really important and scientific way, we are a wave. A quote from David Malone.
Hello, Michael Evans. How you doing?
How you be?
Oh, Michael's in the conversation. Nice. Welcome.
In the group chat, there's a video on the math that's involved in the song.
You have to turn it off now because they're gonna copyright infringe it. You can only play 15 seconds or so. Sorry. That we need to keep an eye on that too, because I don't want anything that happened to our videos, or I can just go through and re-edit it, which would suck.
Yeah.
So thank you for the background music. I appreciated it, and that was my closing. That literally was. I have more to say, but that was a closing remark to that chapter, I guess. Welcome, Michael. Yeah, like I said, I'll keep ranting about my things here, if I could, if you guys don't mind, and then I'll take questions and comments in a little bit here, because this does get somewhere really interesting. The combination of basically Walter Russell, Rupert Sheldrake, my work, and the future of sonobiology and understanding the currents and the communication of creatures, because this is really important, because the pattern on the beetles' shells are telling us something. You guys have seen that I've been releasing this, and you know, the spiders, and this is all part of the Sona biology, the pattern and the pattern recognition. There's things that it's telling us about the vortexture. So two waves often support each other and make each other stronger when they connect. That's a nice little thing to learn or to reinforce. The way light stays with fiber optic channels is similar to the very structure of a Birkeland current. So fiber optic, if you guys understand how it works, it just basically, it's like a solenoid, and it wraps itself around the outside of the conduit, the outside of the fiber, and then all the light comes on the other side, on the face of it. So that's very similar to a Birkeland current. Although waves reflect continually, there's always at least some reflection over time. A wave transitions into a material where the speed is different. Sympathetic vibrations. So when waves transition into other mediums, like I was talking about at the beginning, when it changes the energy state, the hexagonal grid that's on our body, or the octagonal charge grid that's on our surface layer of our skin right now, when you touch something else, it changes, and the charge distribution actually becomes a different geometry on our skin. Whether you see it there or not, it's there, and we know that it's there through static, static charge and things like that. So getting into sympathetic vibrations, and on the larger scale, the cascading resonances that build up this symphonic orchestra that we live inside. Lightning and thunder. This is what gets me into thinking about this. Brontrophonic. Brontrophonic is the sound of thunder. So brontrophonics, and what is the nutrition? Is there nutrition or the nutrients of thunder? I think thunder has nutrients, and the nutrients are in the sound. And the thunder works like a cue, as a catalyst for many things to run or take hide or prepare for the water, or sort of like how animals are in touch with their sixth sense before an earthquake and they run away. That kind of stuff. And those are waves. Lightning and thunder is a wave. Thunder is a wave that's coming off of lightning. And you can count it and categorize it. So the greater the distance of the speed into the two materials, the greater the reflection. Well, we should already inherently know that if the speed of something, if the speed of a wave is moving into something, the greater the reflection naturally, or the dispersion of energy into different forms. Like when a wave laps up on a beach.
That'd be you, buddy.
When a wave laps up on a beach, that is me. It disperses its energy into the sand, into sound, into speaking of the transmission of waves, and from 2-dimension to 3-dimension, and the morphologies of them, this is literally dependent on a bubble. A bubble is what makes that sound, and that's in that documentary as well, and the channel here, and the comments below. The size of the bubble that hits the water, it resonates and makes that. It's not the water enveloping and like creating some sort of like cavity. It is the water, a bubble that's gyrating and oscillating, creating that. which I thought was really cool to think about an oscillating bubble making that noise and putting two and two together. It's a little sphere. So the sounds of spheres. And this brings me into the other thoughts. We covered this a little bit earlier on the episode, but if thunder has nutrients and the sound of it is literally being eaten by everything because it's so voluptuous, whatever, either, or that it you can feel it in the resonance in the chest cavity. You can feel thunder in your chest. And so if you play a healthy coral reef to a dying coral reef, it regenerates it. This is where I want to go with all of this. And this is the future of sonobiology. If you play a healthy gut to a deteriorating gut, will it create a better atmosphere and produce healthy gut and healthy microbiome? And likewise, if you play birds and the right types of birds in a forest, will that regenerate a forest and make it produce certain meandering currents that we would never even think of just because of these little chirps and warbles and wobbles? And that nutrients of a soothing voice. What is in the nutrients of a soothing voice? You know, I can try to calm down. I'm A-type personality and talk more like this and kind of compose my composure like this and get on to the next episode and do pillow talk for NPR. But like, I mean, what energy level do I want to be on? And what energy level are we on? And there is nutrients to a soothing voice. It makes you feel good. So playing soothing voice to yourself or a reassuring voice. Some people play self-help things to themselves for self-reaffirmation that everything's going to be okay because they haven't conquered the fear of death for some reason. As soon as you conquer the fear of death, you're okay. You become a rebel. You are gone. You no longer, death wears your sting. You can do whatever you want. Some people are held back by other things, so I don't want to be presumptuous as well. So playing sounds of a healthy mind to an unhealthy mind. Think about that while you sleep at night. Binaural beats, different things, healthy sounds. What is a healthy sound? A healthy sound to me is a thriving forest. I love the sound of a thriving forest. I love the sound of nature shows. I watch them, I think, just so I can hear the nature. I don't care what's on. But if you play the sound of a thriving forest back to a forest or a moor, will it create more forest? So waves are sticky. They're static. They're clingy. They wrap around walls. They move in straight lines. They move straight through things. They do all sorts of things. They're hyperbolic. It can be described in many different types of geometric modalities. The E8 crystal lattice structure, your model here. What is the tetrions? Whatever the grand thing of the name of Tetri-onyx of your presentation here, the Doherty set, all the stuff. It's part of the same thing, part of the same heart. So to close with, I didn't really get into the wave origins of. Let me go back all the way to the map when this started. Wave origins within the Doherty network. I think I covered it enough, but I'm going to cover it a lot more in my books and other content. A lot of this stuff that I talk about is very brief, and it can't be it can't be thought of like it is the substance. We are just touching lightly on a lot of this content, so that has to be taken with a grain of salt and understood as well. And the more of the substance is going to be inside of the books that we make, and the books, and the more content. So structuralism is the doctrine that structure is more important than function. And how do you agree with that, Kelvin? Structure is more important than function.
Structure is function.
Yeah. Well, if you study structuralism, it's the doctrine that structure is more important than function. So structure is what makes the function. The form, the field creates the forms.
The term that I heard that makes the most sense is form gives way to the advantage of stream.
Okay.
It's a good way to put it too. So I put that on here. That's part of the name of this is structuralism. So you can research that on your own for anybody that's interested. I might put a link in the thing below. We'll see. I probably need to because it's on the title here. Structuralism. I didn't cover helical laws, but the audience is going to have to look that up because I don't have time for all this. We've covered helical law in almost every single episode. If you want to look into that, it's Vladimir B. Ginsburg, helical law, the space-time origin of the universe and prime elements of ordinary matter, and dark energy. It doesn't matter if he's talking about things like space-time, ordinary matter, and dark energy because his concepts make sense. He was trying to make sense of the verbiage at the time. We know that in the electric universe paradigm, we know that dark matter and dark energy don't exist because it's actually this. It's actually waves. It's actually electricity. It's actually charge moving through space and collimated cylindrical Bessel functions. So when you research his stuff, it really gets into it good. Integrated information systems, integrated information theory attempts to explain what consciousness is and why it might be associated with certain physical systems. So Brighton, this is right up your alley and right up everyone's alley on if they're interested in the show, integrated information theory.
Integrated information theory by who?
Check it out. It's a big collaboration. It's a collective. Integrated information theory. Just type it in. It attempts to explain what consciousness is and why it might be associated with certain physical systems, such as the Doherty network, the helicity, helical thinking, helical thoughts, what the tetrions as a physical system, and how consciousness is attached. So here's a couple of things for the audience and for everyone here to attach or to study that could collaborate with their work.
From a synesthesia, an analysis of synesthesia to cryptography, form must exist before information, and then information must exist before any form of communication exists. Wherefore, form is the first construct of existence. Everything derives from form first, and then transcends into cryptographic nonsense. That's a model for consciousness there.
So ultimately, what we're getting at is if this is the field and the field is coming off the sun, and you can see forms being created through pressure and the release of pressure, systolic forms that are both implosive and explosive. The dynamics of implosion and explosion are here using just simple spherical pressure gradients, which is what Walter Russell talks about, and how sound propagates and what sound is made of. So I believe we're harmonizing on many strings and plucking the golden cord, holding the golden candlestick for others to see. And when it marches into Jerusalem and into, which actually we talked with a guy from Jerusalem earlier this week. He's going to be on the Electric View tomorrow. I'll probably join in and have some conversation. He was great. He was giving Neil a lot of criticism that Neil needs to grow stronger. I hope he continues to do it on the recorded phone call. He was just like, what does this have to do with the show? Anyway, So this episode is brought to you and made possible by bubble sculpting. Bubble sculpting, I will be doing bubble sculpting classes this next Saturday in Milford, Michigan. If you're interested, look up woodnotecabin.com. That is where it will be hosted, doing workshops there, and it's already happening. We have sound healers. Apparently, one of the sound healers there was the one who was one of the sound healers of Oprah and Deepak Chopra. So that was cool to meet that individual and vibe on higher levels with these wonderful friends that I've met. And I can't wait to introduce other friends too, and introduce I built a little nest there, and I'm introducing myself to the world. 2020, love is watching, 2020 vision. So this is the nest, and everyone here is part of the nest with the geometric view. So thank you for being here, everybody. I really appreciate it.
Thank you, buddy.
Thanks, buddy.
Thank you.
A lot of stuff's going on this year. So to keep informed, I guess maybe keeping track with my Facebook. You can contact me on Facebook. You could contact Kelvin on his Facebook. And what probably Tetri. Where can we get your information, Kelvin? Also post a link to your website or where we might be able to find it most, and then I can put it in our chat.
There is a Facebook link for Kelvin C. Abraham, and Richard Blankenship was saying Tetri-onyx.com, or maybe it was Tetri-onyx101.com.
Okay, that's what I thought I remember.
Yeah,
because I've been looking into it for years. I just there's so much there, and I'm doing my thing. The world's going on, so I'm so glad that this episode happened and everybody was here to partake in it. Love you all.
Bless you all.
Bye.
See you next week, guys. Have a good weekend. Special thanks to Dan Winter. I'd like to thank Don Scott, Eugene Bagachov, Wallace Thornhill, David Johnson, Terrence Howard, Laird Scranton, Rupert Sheldrake. Check us out on our other podcasts, The Electric View and The Brighton Buddy Show. I also independently interview artists at the Universal Ones Artist Collective on Buddy Doherty's YouTube channel. The Geometric View is Love is Watching product. Special thanks to Jim Weninger. Love is Watching production. Thank you for doing that. Executive producers of the Geometric View are Buddy James and Brighton Cotter. Music is by the acronym Beauty, the acronym BUD, and Abyssal Dionysus is the geometer. That's me and Brighton. Thank you for being here. Catch you next Saturday. Love is Watching. I'd like to say a special thanks to Hartmut Mueller with Global Scaling.